Respected sir, my name is Monica and today I am going to give seminar on the topic logic gates. Basically, logic gates are divided into the following types. So the first one is basic logic gate and continued by universal logic gate followed by special logic gate. So in basic logic gate we have the following types like AND gate, and the symbol, the Boolean symbol for AND gate is like this. Let's take A and B as inputs and the output Y will be A into B, and this is called the Boolean equation. So the logic for AND gate is if both the inputs are 1, the output will be 1, and in all the other cases the output will be 0. Then the next one is OR gate. So the symbol for OR gate is like this. So A, B, and the output will be A plus B. This is the Boolean equation. And so here the logic is if both the inputs are 0, the output will be 0, and in all the other cases the output is 1. Now let's take NOT gate. So in this NOT gate, this is the symbol, and if the input is A, the output will be A bar. That means if input is 0, the output will be 1, and if the input is 1, the output will be 0. So this is about basic gates. Now let's see universal gates. So the very first one is NAND gate. So the NAND gate is symbolized as like this. So A and B are the inputs, the output will be A into B whole bar. So the NAND gate is quite opposite to AND gate. So as I told you, in AND gate, if both the inputs are 1, the output is 1, and in all the other cases the output is 0. So here if both the inputs are 1, the output is 0, and in all the other cases the output is 1. Now let's take NOR gate, and its symbol is this one. So if the inputs are A and B, the output will be A plus B bar. Now here again the NOR gate is also quite opposite to OR gate. In OR gate I mentioned that if both the inputs are 0, the output will be 0, and in all the other cases the output is 1. So here if both the inputs are 0, the output will be 1, and in all the other cases the output will be 0. Now coming with special gates. So in special gates we have XOR gate, and it is symbolized as like this. So if A and B are the inputs, Y will be the output AB bar plus A bar B. This is the Boolean equation. So here in XOR gate, if both the inputs are same, the output will be 1, and if both the inputs are different, the output will be 0. Coming with XNOR gate, it is symbolized as like this. So A and B are the inputs, the output will be A bar B bar plus AB. So XNOR gate is quite opposite to XOR gate. So this is a basic classification of logic gates. Now let's see realization of logic gates using universal gates. That means we are going to convert all the logic gates into universal gates. So like NAND and NOR. So let's take the very first is AND gate, and now I am going to convert this AND gate to NAND gate and NOR gate. So first the Boolean equation of AND gate is Y is equal to A into B. Let me take double bar. So Y is equal to AB double bar, which is nothing but AB. So how can I write this in a gate is like this. So A and B be the inputs. So here I will be getting A B bar, and here I will be getting A, B double bar, which is the required output Y. Now let me convert this AND gate to NOR gate. So here again I am taking Y is equal to A, B double bar. And from De Morgan's law we know that A into B whole bar is equal to A bar plus B bar. A bar plus B bar whole bar. Now let me take A bar. So this is A bar and then B bar. This is B bar. And I am going to connect these two again using a NOR gate. So I will be getting A bar plus B bar whole bar, which is the required output Y. So this is conversion of AND gate to NAND gate and NOR gate. Now let's convert OR gate to NAND gate and NOR gate. So OR gate and the equation Y is equal to A plus B. So now here I am taking double bar. Y is equal to A plus B whole double bar. So again from De Morgan's law we know that A plus B whole bar is equal to A bar into B bar. A bar into B bar whole bar. Now let me represent this here. So let me take A bar. So A bar, and in similar way B bar. And I am going to join these two using a NAND gate. So A bar plus B bar whole bar. Sorry, A bar into B bar whole bar, which is the required output. Now for NOR gate again what I am doing is Y is equal to A plus B double bar. So let me take a NOR gate. So A, B, I will be getting A plus B bar. Another NOR gate, I will be getting A plus B bar double bar, which is the required output Y. So this is the conversion of OR gate to NAND gate and NOR gate. Now let's see conversion of NOT gate to NAND gate and NOR gate. So the equation for NOT gate is Y is equal to A bar. So simple, right? So Y is equal to A bar. So let me write A bar in NAND gate. So this is A bar. If I take input A, the output will be A bar. And if I take a NOR gate, Y is equal to A bar. So here if I take input as A, the output will be A bar. So this is conversion of NOT gate to NAND gate and NOR gate. Now let's see conversion of NAND gate to NOR gate. NAND gate to NOR gate. So the equation for NAND gate Y is equal to A, B bar. So what I am doing is I am going to take double bar. So Y is equal to A, B bar double bar. So from De Morgan's law we know that AB whole bar is equal to A bar plus B bar, as usual the double bar. So let me take A bar, A bar, and then B bar, and joining these two using a NOR gate. So I will be getting A bar plus B bar whole bar. Again joining these two using a NOR gate will be giving the desired output. So conversion of NAND gate to NOR gate. Now let's see conversion of NOR gate to NAND gate. So here NOR gate, the equation of NOR gate is Y is equal to A plus B bar. Now let me take Y is equal to A plus B bar whole double bar. So from De Morgan's law we know that A plus B whole bar is equal to A bar into B bar double bar. So now let me express this in symbolic way. So A bar and then B bar. So A bar, B bar, joining these two using a NAND gate, I will be getting A bar plus B bar whole bar. Again joining these two using a NOR gate, I will be getting a required output Y. So this is a conversion of NOR gate to NAND gate. Now let's see the conversion of XOR gate to NAND gate and NOR gate. So let me take XOR gate, and its Boolean equation is equal to A B bar plus A bar B. So now what I am going to do is Y is equal to A B bar plus A bar B double bar. So from De Morgan's law, we know that A plus B whole bar. Let's consider this as A and this as B. So A plus B whole bar is equal to A bar into B bar. So A bar into B bar whole bar. So now let me express this in a symbolic way. So let's take A bar and then B bar, and then joining these two, and then joining these two using a NAND gate. I will be getting, so here I will be getting, so this is A bar and then this is B bar. Now A B bar, A with B bar. I am joining these two using a NAND gate. I will be getting A B bar whole bar. Then B A bar. B is joined to A bar. I will be getting A bar B. Now what I am doing is I am joining these two again.
Fast.
Using a large NAND gate. So I will be getting a desired output, that is the Y. So this is Y. So this is conversion of XOR gate to NAND gate. Now let's see conversion of XOR gate to NOR gate. So I will be getting Y is equal to A B bar plus A bar B. Let me take double bar. So as I told you, we can write this using De Morgan's law as A B bar whole bar into A bar B whole bar whole bar. So this can be expressed as A bar B bar, A bar plus B bar into same again A bar, A double bar plus B bar whole bar. So which is equal to A bar plus B whole bar plus A plus B bar whole bar. Now let's write this by taking again, let's take double bar. So now let me write this using the Boolean equation. So let's take A bar and then B bar. So this is A bar and then B bar. Now A B bar. So A B bar. So A plus B bar whole bar. Then A bar and then this B. Using a NOR gate, I will be getting A bar plus B whole bar. Now I am going to connect these two again. I will be getting, so I will be getting here A bar plus B bar plus A plus B bar whole bar. Now again if I connect this using a NOR gate, I will be getting the required output Y. So this is a conversion of XOR gate to NAND gate and NOR gate. Now let's see the conversion of XNOR gate to NAND gate and NOR gate. So the Boolean equation for XNOR gate is Y is equal to A bar B bar plus AB. Now I am going to take double bar. So Y is equal to A bar B bar plus AB double bar. So this is our form A bar plus B bar. So A bar plus B bar is A bar into B bar. So A bar B bar whole bar into A B bar. Let's take a double bar as this. Now let me represent it. A bar B bar. Now let's see A bar B bar. So A bar into B bar whole bar. Then A B bar. So let me connect these two also. So A B whole bar. Now if we connect these two, we will be getting the desired output as Y. So this is a conversion of an XNOR gate to NAND gate. Now let's see the same thing with NOR gate. So Y is equal to A bar B bar plus AB double bar. So which is equal to A bar B bar whole bar into AB bar whole bar. So what I am doing this is of a form AB bar. So we can write this as A bar plus B bar. So A bar plus B bar into same thing here also A bar plus B bar whole bar. So again this is of the form A into B. So what I am going to write is A plus B bar plus A plus B bar. A bar plus B bar whole bar. Let me take double bars so that we can represent it using the logic NOR gate. So let me take A bar and then B bar. So this is A bar and B bar. So now we are taking AB. So let me take this. Sorry, AB. So let me connect these two using NOR gate. And then A bar B bar. So here I will be getting A bar plus B bar whole bar. Here I will be getting A plus B bar. Now let me connect these two again. I will be getting A bar plus B bar whole bar plus A plus B bar whole bar. If I join this with another NOR gate, I will be getting the desired output as this. So this is the conversion of XNOR gate to NAND gate and NOR gate. So this is all about logic gates classification and realization of logic gates using universal gates. Thank you.